Hello everyone, welcome to my YouTube class. In this video we are going to talk about the equilibrium index of an array. Now what is the equilibrium point? A point where the weight on either side will be equal. Similarly, in an array, an equilibrium index is the point where the sum of LHS subarray is equal to sum of RHS subarray. Now, there might exist an equilibrium index or there may not exist an equilibrium index in an array. Or there might be existing more than one equilibrium index in this array, in any array. In this program, we are going to give the answer as the first equilibrium index only. Now, say for example, if this is the array 10, 20, 30, 40, 0 and 100, you can see that 4 is an equilibrium index. Why? The sum of LHS 0, 1, 2, 3. The sum of LHS at index 0 to 3 is 100 and the sum of RHS is also 100. That means the weight on the LHS of 4 is equal to the weight on RHS of 4. Therefore, 4 is called as an equilibrium index in this array. Let's take the next example. -7, 1, 5, 2, -4, 3 and 0. In this case, 3 is the equilibrium index. Therefore, why? Because the sum of LHS is -1 and the sum of RHS is -1. See here, this is -4 plus 3 is -1, -7 plus 1 -5 is -1. That means the weight on the LHS of index -3 is -1. On the index -3 on the RHS is also -1. Therefore, 3 is an equilibrium index. Now, take the example 10, 20, 30. Now, in this case, there is no equilibrium index. Why? If I consider 0 as the equilibrium index, sum of LHS is 0 because there are no elements and sum of RHS is 50. If I consider 1 as the equilibrium index, sum of LHS is 10. Sum of RHS is 30. Therefore, this is also not equilibrium index. And if I consider 2 as equilibrium index, what is sum of LHS? 30 and sum of RHS is 0. Therefore, 3 is also not an equilibrium index, which means there exists no equilibrium index in this array. Hence, we give answer as -1. Therefore, answer we give it as -1. Therefore, it says if such index exists, you return that index for 3, and if it does not exist, then you give -1 as answer. This is what the equilibrium index is. Now, please pause the video over here and give it a thought how we are going to solve this problem. I am just going to give a hint as of now. The hint is use the cumulative frequency. Thank you. Please pause the video. Think how do you solve the problem using the cumulative frequency that you have studied in the statistics in school. Thank you. Let us see how do we solve the problem on the equilibrium index. Suppose this is the array 10, 20, 30, 40, 0, 80 and 20. Clearly 4 is the equilibrium index. Sum of LHS is 10, 20, 30, 40 which is 100. Sum on RHS of 4 is 80 plus 20 which is 100. Therefore 4 is the equilibrium index. Now how we are going to solve this problem? I said using the cumulative frequency. Now, what is cumulative frequency? Cumulative frequency gives sum till that point of time. It gives sum till that point of time. Now, if I say cumulative frequency of this array and I want to calculate from LHS and I want to calculate it from the LHS. Now, this is index 0. What is cumulative frequency? Now, you might have done in school if you have written 10, 20, 30, 40, 0, 80, 20. If these are the frequencies, how do you find the cumulative frequency? You write 10 as it is, then you say 10 plus 20 is 30, 30 plus 30 is 60, 40 plus 60 is 100, 100 plus 0 is 100, 100 plus 80 is 180, 180 plus 20 is 200. This is the way you write the cumulative frequency. Similarly, first you write the same element as it is 10. Now what we do at index 0, whatever is the cumulative frequency, you add with the next element. Now this is 10, you add with the next element. What is 10 plus 20? 30. Is that okay? Now it means, what does cumulative frequency of 1 means? It means sum till index 1 is 30. It means sum till index 1 is 30. Now I want cumulative frequency of index 2. 30 plus 30. What is 30 plus 30? 60. Now what does cumulative frequency of 2 means? If I say cumulative frequency from LHS is 2, It means sum from index 0 to 2 is 60. You need not compute again. You just go to cumulative frequency of 2. You will get the answer. Now what is cumulative frequency of 3? 60 plus 40. What is 60 plus 40? 100. What is cumulative frequency of 4? 100 plus 0 is 100. What is cumulative frequency of 5? 100 plus 80 is 180. What is cumulative frequency of 6? It is 180 plus 20 is 200. Now, if I ask, get me the sum till index 4. How will you do? Again, will you start from 0 plus 1 plus 2 plus 3 plus 4? No. You just go to cumulative frequency array and you need cumulative frequency till 4. Hence, I say cumulative frequency from LHS till index 4. It gives answer as what? 100. That means sum of all elements from 0 to 4 is 100. You need not compute again. You need not compute again. This is the answer is stored. Now, cumulative frequency says answer or sum till that point of time. I should not say answer, it is sum till that point of time. Now similarly, let me compute cumulative frequency from the RHS. Similarly, let me compute the cumulative frequency from the RHS. Now what is from the RHS at index 6? You write 20 as it is. Now what is at index 5? 20 plus 80. What is 20 plus 80? 100. Now you want cumulative frequency at 4. What is at 4? 100 plus 0 is 100. Is that okay? Now you need cumulative frequency at 3. 100 plus 40 is 140. You need cumulative frequency at index 2. What is at index 2? 140 plus 30 is 170. You need cumulative frequency at index 1. 170 plus 20 is 190. And cumulative frequency at index 0 from the RHS is 200. Now it means if I come at this point of time at index 0, what does it mean? Sum from LHS of this subarray is sum of LHS of subarray till this point of time is 10. And what does it mean? Sum of the RHS subarray from 6 to this point of time is 200. Is that okay? Now you see that at index 4 the value clearly match. At index 4 the value clearly match. Now what does it mean? It means cumulative frequency of LHS. It says sum till index 4 from LHS is 100. Sum till index 4 from LHS is 100. And what does this 100 says? Sum from RHS till index 4 is 100. Sum from RHS till index 4 is 100. Are you getting it? What does it say? Sum from LHS till index 4 is 100. Sum from RHS till index 4 is 100. That means sum from LHS is equal to sum from RHS. Therefore, what should be the equilibrium index? 4 is the equilibrium index. Now what we do? We compare. Is 10 is equal to 200? No. That means sum till LHS is 10. Sum from RHS is 200. Now sum of LHS is not equal to sum of RHS. Therefore 0 cannot be equilibrium index. Go to the next thing. Can 1 be the equilibrium index? Sum from LHS from 0 to 1 is 200 and sum of RHS of 1. What is sum of RHS of 1 here? 30 plus 40, 70 plus 80, 150 plus 20. 170 plus 20 is 190. Sum of RHS of 1 including 1 is 190. Are you getting it? Sum of RHS of 1 including 1, sum of RHS of index 1 including index 1 is 190. Sum of LHS of 1 including index 1 is 30. Now is 30 equal to 90? No. That means sum of LHS of index 1 is not equal to sum of RHS of index 1. Therefore, it cannot be the equilibrium index. Now similarly, this cannot be equilibrium index. Same explanation. Sum of RHS of 2 including index 2 is 170. See here, including index 2 I am saying 30 plus 40 is 70, 70 plus 80 is 150 plus 20 is 170 and sum of LHS 30 plus 20 plus 10 is 60. Now sum of index 3 from the LHS is 100 including index 3. Sum from RHS including the index 3 is 140. Therefore, this is also not an equilibrium index. Now, sum till index 4 including index 4 is 100. Sum till index 4 from the RHS including the index 4, 80 plus 20 plus 0 is 100. That means sum of LHS is equal to sum of RHS. Therefore, 4 is an equilibrium index. Are you getting it? Now, how many extra arrays we are using it? 2 extra arrays we are using it to compute the cumulative frequency from LHS and to compute cumulative frequency from RHS and to compare element by element. Wherever you find equal, that particular index is the equilibrium index. Is that okay? I want you to pause the video and write down the code. Thank you. Now let us write the code of the equilibrium index using 2 extra arrays, one to find the cumulative frequency from LHS and other to find the cumulative frequency from RHS. Now after this I will explain you the method how you can do without those 2 extra arrays, and I will leave as an assignment to do yourself that code without using any extra arrays. Now here I am using some extra arrays, that is cumulative frequency from LHS and RHS. This is method 1. Let's code using this method. We say int main and hash include stdio.h, any other function prototypes appropriately you need to write it down. Let's declare an array. Let me say int a of 100. You can declare int a of 1000 or something, I don't mind it. What will happen? An array A will be created in the main scope. This is the array A with index 0, 1, 2, 3, 4, 5, 6, 7 and so on up to 99. This is array A. Now we can store n elements in this array. Therefore, I again say int n and read the value of n. Scanf %d %n. Now let the value of n be say 6 or 7. We want to store 7 elements. 7 means 0 to 6. And how do we store the elements over here? We call the read array function, and you have to implement the read array function yourself. I write it here, read array. This is not a inbuilt function, mind you. Read array is a user defined function which you have to write it. Which array you want to read it? A. And how many array elements are there? There are n array elements. And let us read the value as 10, 20, 30, 40, 0, 80 and 20, where 4 is the equilibrium index. Now let us write one function called as equi-index. Let me write one function called as equi-index, which will give us the equilibrium index. In this case, the equilibrium index is 4 if available, and if it is not available, it will give answer as -1, because -1 cannot be the index. Where I need to find the equilibrium index? In this array A. And how many array elements are there? There are n array elements, and there are n array elements. I close the main as of now, and let us see how do we write the equi-index function. The return type of the function is integer, clearly, because you will return the index. Indexes are always integer, or you return -1 if the equi-index is not found. And I write the function name as equi-index. What is the first parameter? Integer one-dimensional array, and the second parameter is integer n, Okay. Now what I need to do first? We need to construct 2 arrays. One is cumulative frequency of LHS, the other one is cumulative frequency of RHS, so that I can compute the cumulative frequency from the LHS and RHS. And what should be the size of cumulative frequency of LHS? Suppose the value of n is 100, cumulative frequency of LHS will have 100 elements, cumulative frequency from RHS will also have 100 elements, because maximum size of the array is 100. Hence, let's declare 2 arrays, and I say int CFL. CFL means cumulative frequency from LHS of 100 elements, and one more array I need it, int cumulative frequency from RHS of 100 elements. There are 2 methods again I am saying. I will explain one more method where you do not use these 2 extra arrays. I am saying how to use these 2 extra arrays so that you know how do you code by taking the extra arrays as well. Now this is cumulative frequency of LHS 0, 1, 2, 3, 4, 5, 6, 7, so on up to 100, so on up to 99, I'm sorry. And cumulative frequency of RHS, now this is cumulative frequency of RHS 0, 1, 2, 3, 4, 5, 6, 7 and so on up to 99. That means cumulative frequency of LHS means from LHS we are finding the cumulative frequency. Cumulative frequency of RHS means from RHS we are finding the cumulative frequency. Let us first find the cumulative frequency from the LHS. Now what is the first step that we are going to do? The first step we are going to do is copy this 10 here as it is. Copy the 10 here as it is. And how do I copy here? I say cumulative frequency of LHS of 0 is equal to A of 0. Is equal to A of 0. 10 is copied here. Now from index 1 till index 6, I need to find the cumulative frequency. Hence we write from the index 1, therefore we say I is equal to 1, I less than n, and I write here I plus plus. Now how we are going to compute the cumulative frequency at the index 1? How do I write it? Cumulative frequency of LHS of I. Now what is the value of I? The value of I is 1. Hence I say cumulative frequency of 1 is equal. Now say me, what should I write? What should I write over here? The previous value plus 20. That means how do I get the previous value? Cumulative frequency of 0 plus the current value which is A of 1. Now what is cumulative frequency of 0? It is 10 and the A of 1 is 20. 10 plus 20 is 30. That is what I need to write here. Now if you see this, if the value of I is 1, how will you get 0? How will you get 0? Cumulative frequency of, what shall I say? I minus 1 plus. If here it is 1, you get the same 1 over here. Hence what do I write? A of I. Hence I write A of I. Is that okay? Therefore you get 30 and 30 is stored over here. I hope no questions. You say I plus plus, the value of I becomes 2. Cumulative frequency of 2 is equal to minus 1 is 1 plus A of 2. Now what is cumulative frequency of 1? 30. You have to say 30 plus 30. See here. Cumulative frequency of 1 plus A of 2, 30 plus 30 is 60. Similarly, you say I plus plus, I becomes 3. Cumulative frequency of 3 is equal cumulative frequency of 2 plus A of 3. Cumulative frequency of 2 plus A of 3. 60 plus 40 is 100. 100 plus 0 is 100. 100 plus 80 is 180. 180 plus 20 is 200. I plus plus 7. 7 less than 7 is false. You come out of this loop and what do you observe? You observe that the cumulative frequency from the LHS is being populated, is being computed. Now I want to compute cumulative frequency from the RHS. Now how do I compute the cumulative frequency from the RHS? Now this computes cumulative frequency of LHS. This computes cumulative frequency from LHS. How do we compute cumulative frequency from RHS? Now the last value 20 has to be written as it is. Now can anyone say me how do you get the last value? If the value of n is 7, how do you get the last value? Yes. Cumulative frequency of RHS of n minus 1 is equal to A of n minus 1. N is 7, 7 minus 1 is 6, and at this point of time you write 20 as it is. Now I need to start from index 5. Therefore, how do you get 5? The number of elements are 7, and how 7 and 5 are related? Yes, say me how 7 and 5 are related. I say I is equal to n minus 2. Is that okay? Therefore, the value of I will be 5. And till what point of time I need to go? Till I reach 0. Therefore, and it is from 5, next time it will be 4, next time it will be 3, and so on. Hence I say I greater than or equal 0, I minus minus. I is n minus 2, I becomes 5. 5 greater than or equal to 0 is true. Now at this index, what you should write? 20 plus 80. Are you getting it? You have to say 20 plus 80. Now, therefore, I write here cumulative frequency of RHS of I is equal to. Now, the value of I is 5. I need to get the value of I as 6. How do I get it? Cumulative frequency of RHS of I plus 1. Now, I plus 1 is 6. You get 20 plus 80. Plus what shall I write? A of I. The value of I is 5. 5 plus 1 is 6. Cumulative of RHS of 6 is 20. A of I is 80. 80 plus 20 is 100. And you store 100 at this point of time. I minus I becomes 4. 4 greater than or equal to 0 is true. Cumulative frequency of RHS of 4 is equal to cumulative frequency of 5 plus A of 4. Therefore, I say 5 plus A of 4. Now, what is cumulative? It is 5 is 100 plus 0 is 100. Now, it is 100 plus 40 is 140. You do it. 140 plus 30 is 170. Here it will be 190. Here it will be 200. Needless to explain, I minus at the end it becomes minus 1. Minus 1 greater than or equal to 0 is false. You come out of this loop and you see that the cumulative frequency of the RHS is also computed. Is that okay? You have to trace it and you will get to know. Now, after you compute cumulative frequency of LHS and RHS, what I need to do? I need to compare. Is 10 equal to 200? Already I explained why you should compare. Is 10 equal to 200? No. Go to the next element. Is 30? Now, what does 30 represent? Sum till index 1. And what does 200 represent? Sum till index 1 from the LHS. Now, that means this is sum of LHS and this is sum of RHS. Now, sum of LHS is 30, sum of RHS is 190. 30 is not equal 190. It is not equilibrium index, no equilibrium index, no equilibrium index. It is same and it is an equilibrium index and it is an equilibrium index. That means I need to compare element by element of the two arrays LHS and the RHS. How do I compare it? I say for I equal 0, I is less than n, I plus plus. Okay, because I need to compare each element. What shall I say? If cumulative frequency of LHS of I is equal cumulative frequency of RHS of I. If it is so, now the value of I is 0, cumulative frequency of LHS of 0 is 10, cumulative frequency of RHS of 0 is 200. Is 10 equal to 200? No. I plus plus I is 1. Now, is 30 equal to 190? No. I plus plus 2. Cumulative frequency of LHS of 2 is 60. Cumulative frequency of RHS of 2 is 170. 60 equal to 170? No. I plus plus 3. 100 equal 140? No. I plus plus 4. Cumulative frequency of LHS of 4 is 100. Cumulative frequency of RHS of 4 is also 100. That means at index 4, sum of LHS is equal to sum of RHS. Therefore, I should be the equilibrium index. Hence, what do I write over here? Return I. Hence, what do I say? Return I. Still, the function of equi-index is not yet completed. Now, what is the value of I? 4. Now, it becomes essential for me to store it in some variable, and let me store it in some variable called as E. Now, what is the value of E? The value of E is 4. The value of E is 4. Is that okay? Now, if it is not found, what you should return? You should return minus 1. Already I said it. Therefore, I write here, if the value of E is equal minus 1, printf no equilibrium index. No equilibrium index. Else, what is the equilibrium index? In which variable it is stored? You have to say printf %d, E. Print the value of E. Print the value of E. Is that okay? Now, let us see how does it will say not the equilibrium index. Now, let us say the array as 10, 20, 30 only. There are 3 elements. Let us say the array elements are 10, 20 and 30. Only 3 array elements are there, and we will see how does it finds. Now, we know that cumulative frequency of LHS is 10, 30, 60. Needless to say, it will be 30, 50, 60. Needless to say, you explain it yourself. You trace it yourself. Cumulative frequency of LHS of 0 is 10, RHS is 60, 10 equal to 60, no, I plus plus 1. 30 equal to 50, no, I plus plus 2. 60 equal to 30, no, I plus plus 3. 3 less than 3 is false. You come out, it means no equilibrium index. And if no equilibrium index, what you should return? We should return -1 and we stop the code over here. Now -1 will be returned, E is -1, -1 equal -1, and it says no equilibrium index. This is how we find the equilibrium index using the cumulative frequency method. Now the second method is also cumulative frequency method, but I'm not going to use extra arrays. Here we have used extra memory, extra arrays. This is good method, very good method, but the overhead is you are using extra memory, extra space. Can we do without using extra array, without using extra memory? Yes, we can do it. And wait, I'm going to explain it, but till that point of time, think it. Again, I'm going to give you an hint. The hint is find sum of an array and try to think what you can do from there. Thank you. Let us see the method 2 of finding the equilibrium index. Now this is the method 1 where you have found the cumulative frequency. Here also we will do with cumulative frequency, but we don't store in an extra array. Now again the same thing, the main function remains same. You take int a of 100, take the value of n, anything, read the array, call the equilibrium index function, but here the logic will change. But the equilibrium function will return the same thing, -1 not found, and that particular index if the equilibrium index is found. Now what we do over here, this method you have to write code yourself. I'm not going to write the code, I'm just going to explain you the method. What is the sum of this array? What is the sum of this array? 10 plus 20, 30, 60, 100, 180, 200. Sum of this array is 200. Sum of this array is 200. Now, again I need left sum and the right sum to find the cumulative frequency. Now I say right, which means the right sum, which means the right sum, which means the right sum. And I will take one more variable called as left, which means the left sum, which means the left sum. Okay, which means the left sum. Now say me one thing, at this point of time, at index 0, the value is 10. What is the right sum? What should be the right sum? Yes, say me. What should be the right sum? Yeah. No, yes, say me, what should be the right sum? 20, 30, 50, 40, 90, 80, 170, 20, 190. First way of computing it. What is the other way of computing it? Yes, say me, what is the other way of computing it? Now sum of all array elements. What is sum of all array elements? What is sum of all array elements? 200. Now I should not consider this. Therefore what I should do? Say me. 200 minus 10 will give you 190, right? That means sum of all array elements except this array, except this element is 190. That's so simple. That's so simple. Therefore, at index 0, I write here. Let me write it this way. Right sum. Okay, let me do it this way. Right sum, left sum at index 0. What is right sum? How do you get the right sum? You say me. Initially, what should be the right sum? Initially, the right sum should be 200 because we assume that we are at this point of time and this complete thing is right. Therefore, right sum is equal to sum. Hence, I say right is equal to sum and it becomes 200. And what is the left sum initially? The left sum is 0 initially. It's 0. Now, at index 0, what is the right sum? Right sum is 190. And how you are going to get 190? Say me one thing. You say right is equal to, right is equal to what? Right minus a of I. You say right is equal to right minus a of I. Now when I say right minus a of I, 200 minus 10 is 190. And what is the left sum, you say me? Now what is the left sum at index 0? It is still 0. Are these two equal? No sir. That means at index 0 RHS is 190, LHS is 0. Therefore 0 is not an equilibrium index. You would think how to code it. I am saying the method. you say I plus plus I becomes 1. Now, what is the value of right at this point of time? Right is equal to right minus a of 0. The value of right will become 190. Okay. Now, at this point of time, at index 1, what is the right sum? 30, 40, 70, 80, 150 plus 20 is 170. Now, that means from sum, if I remove 10 and 20, 10 plus 20, if I remove 10 plus 20, I get 170. Now, the current value of right is 190, I'm sorry. 190 minus 20 is what? 170. And what is the LHS sum till this point of time? It is 10. And how do you get 10? You say left is equal to left plus a of I. You say left is equal to left plus a of I. It is 10. Is 170 equal to 10? No. 1 is also not an equilibrium index. Now you go to index 2. What is the right sum of index 2? 40, 80, 20, 140. And how do you get 140? Very simple. The current sum of right is 170. And you say 170 minus 30. And what is 170 minus 30? 140. 140. And what is LHS sum of 30? LHS of index 2, it is 30. 10 plus 20. Left plus a of I. Left was 20, 10. 10 plus 20 is 30. The value of left will become 30. Is 140 is equal to 30? No. 2 is also not an equilibrium index. Now you go to index 3. Now what is RHS sum? It is 100. And what is LHS sum? It is 60. How do you get it? Now till this point of time, now I have to, from 200, I have to extract all those things. I have to remove all those things. Now 140 minus 40. What is 140 minus 40? 100. 140 minus 40 is what? 100. Is that okay? That means RHS sum from the index 3 is 100. Now what is the LHS sum? 10 plus 20 plus 30. Already you have 10 plus 20. Now you add 30 as well. It becomes 60. Are you getting it? Now LHS is 100. Now RHS is 100. LHS is 60. Are both equal? No. Now let's go to the index 4. Let's go to the index 4. Now what is the RHS sum? You have to subtract 0 from 100. You will get 100 only. And what is the LHS sum? 60 plus 40. And what is 60 plus 40? 60 plus 40 is also 100. Now is 100 is equal to 100? Yes. That means 4 is the equilibrium index. That means 4 is the equilibrium index. Is that okay? Please pause the video and try to write the program yourself. Let us see how do we write code for the explanation that I gave. What is the first thing? First thing is to find the sum of the array. Initially, what should be the value of sum? The value of sum is 0. Please see here. And we need two elements. What are the two things that we need? It right and left. Right and left. Let the value be garbage initially. Let's find the sum. How do we find it? For I equals 0, declare the variable I less than n, I plus plus. And how do we find sum? Needless to say, sum is equal to sum plus a of I. Needless to say this one. Sum is equal to sum plus a of I. What will be the value of sum? The value of sum is 200. The value of sum is 200. Okay, now at index 0, say me, at index 0, okay, let us assume that we are at this point of time. We are here before index 0. Assume that we are at minus 1. There is no index minus 1. Assume that we are at minus 1. What is the RHS sum? It is 200. Therefore, now what shall I write? Right is equal to sum, because RHS is equal to sum of array. Here you find sum of array. And what is RHS is equal sum of array. Now at this point of time, what is the LHS sum? It is 0. Hence I write here left is equal 0. Hence I write left is equal 0. Okay. Now we have two more variables. Right is equal sum. Left is equal 0. I need to find is 0 equilibrium index, 1 equilibrium index, 2 equilibrium index, so on, so on, so on. We say for, check for 0 as equilibrium index, and you have to check each element, each index is equilibrium index or not. You have to check each index is equilibrium index or not. Now say me the value of I is 0. What is the left sum? Left sum is 0. Already we have left sum as 0. So do not compute the left sum. Now say me, what is the right sum? Right sum is 190. And how do you get the right sum? You say right is equal to right minus a of I. Right is equal to right minus a of I. Right is 200 minus 10. 200 minus 10 is 190. Now at index 0, RHS is 190, LHS is 0. Can it be equilibrium index? No, but I need to compare right to say no. Hence I write, if a left is equal right, then what should be the equilibrium index? I should be the equilibrium index. Now left is 0, right is 190, LHS sum is 0, RHS sum is 190. Boss, it is not equilibrium index. Now if it is not equilibrium index, 1 can be the equilibrium index. Now that means I need to compute the left sum, and I say left is equal to left plus a of I. Now what is the value of left? 0. 0 plus 10 is 10. That means for index 1, I am computing this for index 1. This is for index 1 advanced computation. Now at index 1, the LHS sum is 10 and I need to compute the RHS sum, which I am going to do it now. I plus the value of I is 1. Right minus a of 1. Now what is right? 190 minus 20 is what? 170. That means on the RHS of index 1, the sum is 170. Compute it. And on the LHS of 20, the sum is 10. It is therein. Now these two should be equal in order for the equilibrium index. Is left equal right? No sir, this is not equilibrium index. Therefore you compute. Now this step is computing for the next index. Now you say left is left plus a of I. Now 10 plus 20. What is 20 plus 20? It is 30. What is 10 plus 20? It is 30. Now what does it means? Again you say I plus the value of I becomes 2. Now the sum of LHS is 30, which is stored in left. Now I need to compute the sum of RHS. Right minus a of I. Right is 170. 170 minus 30 is what? 140. Now the RHS sum is 140. You compute it. Now is 30 equal to 140? No, it's not an equilibrium index. Therefore you prepare for the next iteration, and again you say left is equal to left plus a of I. Now the value of I is 2. I'm sorry, I write it here. The value of I is 2. 30 plus 30 is 60. Now again you say I plus I becomes 3. Now at index 3, what is the sum of RHS? It is 100. And how do you get it? Right minus a of 3. 140 minus 40. 140 minus 40 is what? 100. That means the RHS sum is 100. I need to get the LHS sum. And how do I get the LHS sum? Already it is there in left, which is 60. Again you compare, is 60 equal to 100? No. Now next again you prepare for the next iteration, so that you will check that the fourth index is equilibrium index or not, and you need sum till index 3. Left is equal to left plus a of I. 60 plus 40. What is 60 plus 40? 100. You say I plus the value of I becomes 4. Now that means you need RHS sum. And how do you get RHS sum? Right minus a of I. Already I said it, because it's kind of cumulative frequency. And from sum you are subtracting this and that, you will get it. Now what is the value of right? 100. A of 4 is also 0. 100 minus 0 is 100. Now at this point of time, the left sum is 100. The right sum is also 100. 100 equal 100. Yes. Return I. The value of I is 4. It returns 4 at this point of time. Now assume that I becomes equal to n and LHS is not equal to RHS at any point of time. Then what you write over here? You say return minus 1. And how do you solve this? You take an array 10, 20, 30 where no equilibrium index is found, and you see that it returns minus 1. And this is the more efficient way of doing it, because we are not using any extra memory and neither we are using any nested loops. This finds the sum of array. RHS of sum of array will be sum. LHS sum will be 0. You remove that particular element, you get the RHS sum. You add that particular element, you get the LHS sum. You compare. If both are equal, that means that would be the equilibrium index. This is how we find the equilibrium point in an array. Thank you friends for watching this. I hope you have enjoyed this video. Thank you.